Testing. Andrew, can you hear me?
Hello.
Yes, Andrew, I can hear you. All right, videos there. Are we seeing your table, just to confirm?
Yes, the table.
Right. When you're ready to set up, when your setup is ready, you tell me. Huh?
Yeah, I'm ready already. Just getting the Jamboard.
I'm just referring to our past Jamboard, right? In page 1, I realized I have asked you about your physics class and your chem class. Okay. Okay. Yesterday we were talking about. I was talking about the same thing with Aiden. Do you happen to know Aiden?
May I know his surname?
Surname Chong. Is it
Aiden
Chong?
Chong.
No, that's her mom's name. Her mom's name is Chong. So I'm not sure whether that's his surname.
I think I might know him.
Right. Your mom knows his mom lah.
Yeah.
Okay. So then there's a recommendation thingy, and then Aiden. I just meet Aiden, and then we have been doing some tuition, right? Now, I was asking him about why he wants physics and chem tuition also. Same thing, right? Same thing with you. And I think he says something very similar to you. He said that his physics teacher is explain the basic, nice, but he does not give you the practices at a good timing. He seems to give you the exam practices a bit too late.
Yeah.
As your record, same thing. So is it possible that you and him have the same physics teacher?
No, we if I'm right, we don't have the same physics teacher.
Right.
Chem is definitely not the same. No.
Okay. So he was saying that because he rate his physics teacher also around 6.5. Maybe that's just a coincidence, but he rate his current chem teacher higher than yours. I see the Jamboard, you say, oh, it's around 2. And then he say he will be changing chem teacher.
Yeah, he's changing class.
Into another class, which is another teacher, which might be the same as yours.
No, I think I'm my class the only class taught by this chem teacher for our level.
Okay. There's one more reason why I'm asking you all this. So from his impression, about his previous chem teacher, his previous chem teacher is okay lah, not so bad, not so good. He's going to change to another class, and rumor has it, everybody says, but nobody knows for certain right now. But no, everybody say that, oh, the teacher he's changing into will be bad.
Yes, I can confirm that because I have a friend in the class that he's changing to.
And you are saying that your chem teacher is worse than that? Basically.
I haven't been taught by that teacher, so I can't say.
Okay. I'm very confused. So in your school, SJI, there are 3 chem teachers for Sec 3 and Sec 4. 3.
I'm not too sure about that. Yeah,
Right.
but around that number.
Okay. Wow. Okay. Right. So, but that's just me finding out the class situation. The good news is for him, he is assuming that the AA3 plan is about the same the topic lah. Then he already knows one future topic in term 3. We're already trying the exam level questions lah. he is already revising the acid-base solubility also. So let me confirm with you, you also should have talked about acid-base and solubility, I think.
Yes.
And that happens before holiday, and that the solubility one at the very least will be in WA3. Is that what you will be using?
I've not been told yet, but I think it should be.
Because it was not, the solubility part was not in the previous exam.
Yes, it wasn't.
Then let me confirm a few things. You haven't learned what they call ammonia chapter also?
No, ammonia. No, haven't started.
According to Aiden, that will be the next one going into term 3. And then after that, there will be the chemical calculation, which I'm guessing will be called the mole concept and the balancing of equation. Let me confirm with you, balancing equation and mole concept is not yet taught.
No. The balancing equation.
Yes, which is like one of the most. So it goes like this lah. The acid base and solubility, that's one. Okay. Balancing of equation, number 2, and mole concept, number 3. All these 3 can just go into other chapters. I'm not sure how this makes sense. They will go into other chapters and be used in other chapters.
Okay.
Like the quadratic equation in secondary 2. You will find them in so many other topics because that's why you're learning them, because you can and you have to use them in other topics. In AMAT, for example, you're already learning the polynomials, right? The cubic one, right?
Yeah.
And you will also still be using quadratic there, something like that. Later on, you will learn binomial, which is higher power A, then you still encounter quadratic, something like that. And nobody seems to complain, hey, how come I learned quadratic already? How come it's still appearing in this new topic? Nobody is complaining. In that sense, that's a foundational topic. No? Now, I'm telling you and Aiden, the acid-base solubility, the concepts there, then the upcoming mole and balancing will be considered foundational in that sense. Right. So I was very interested in covering him quickly. He's done. He's now currently doing the physics part, right? So I'm also looking to cover that with you. Now that I realize both of you are saying your chemistry class will also be, not very good even in term 3. That's my plan. No? That's my plan. First thing first. If you have any objection or if you think you need to do something else in chem, we should discuss them right now.
No, I don't have any.
Right. Aiden also told me that there isn't much homework for chem, and is that correct for you also?
Isn't much homework.
Right. My point is this. Those are the 2 good things to do to review those topics that I mentioned. That will make your term 3 very stable, regardless of the class quality. That means you can still learn chem properly, right? That's the first thing to do. The second thing to do is to do the homework, right? Now, what kind of homework do you have right now for chemistry?
He just usually gives like each worksheet. There's only about 1 or 2 worksheets. Then they will just be doing like exam style questions.
You're saying that this will be on past topics,
Yeah, past topics.
The solubility and the QA because sorry, I think you also covered QA before holiday qualitative analysis, identification of gas, identification of I know, and yes, those things. So the homework should be those topics Okay, so even though you are in a different class than Aiden, I think you are around that same path, so I think we can assume that your term 3 plan should also be the same, even though class is different.
Yes.
Anything else that you want to share with me regarding chem? Anything?
Chem. Not much to share anymore.
So I think, wait, I think there is a third thing to discuss, which is maybe the chemistry exam, the last one. That's the third thing, but I think that's number 3. It might be more important to discuss the future topics and the homework first. So if you really want to talk about that past exam, we can talk about it afterwards. Suspect if you do a good revision, it wouldn't matter too much right now, probably. Okay. So those are the order that I propose we do chemistry this holiday. Now, chemistry seems to be a priority compared to physics for Aiden, and I'm guessing it is also like that for you. Is that correct?
Not so much.
You tell me.
I think it's both, honestly, because I think for now I'm still scoring higher in chemistry than in physics.
Surprisingly.
Yeah.
Considering that your class you rate 2.
No, because I think that physics really needs practice, and I think I kind of like that.
And you're saying that your physics teacher do not give you enough practice material.
Yes, until like right before the exam.
Which is what Aiden also say on us. But you know what? No matter how bad a math or chem teacher is, they usually give you a lot of practice. So if you just do that and you understand it, that would be very helpful. But physics teachers sometimes do have the tendency of giving too little practice and then too easy practice. Okay.
I think the practices are too easy. They're just, I think the level of the question is around the same as what comes out in the exam.
The problem is it is given to you too late, right?
Yeah.
Which is about the same.
Yeah.
Better than nothing, but we cannot rely on that. It doesn't have to rely on that because of the timing, right? So good news is Aiden just started physics, right? Gonna continue next week. So I'm scheduling your timing with him, and then we will be discussing that. Now, a bit of let's plan a bit on the physics. We were really trying to discuss pressure again.
Okay.
Teacher cover slide already. Finish. Right? Also do some small worksheet already. Then that means in his teacher style, it's time to move on to the next topic. Right? But I asked Aiden, so how comfortable, not comfortable at all with what has happened in pressure, partly because he feels he doesn't understand, even though the easy questions can do. So I just grabbed another student pressure question, which is usually not very difficult, usually more difficult and definitely up to the exam level. And turns out that Aiden has been at least enjoying that. That seems to be what he needs, right? So what is your situation on pressure?
Yes, I also get all the basic stuff, but some of the more complicated questions I struggle a bit.
So for the other student called Joshua, right? Maybe you have met Joshua once, maybe, right? At least his physics teacher is not the average, meaning that he actually drops the student a lot of question even before the chapter is done. So that means you do yourself in holiday. That doesn't make a lot of sense to do it by himself, but we have been benefiting from it. Because he simply do that, he's now having a good understanding about pressure without the class. So let's try that, because Aiden, I tried that once with Aiden yesterday. I'm gonna try that with you today. Right. So I take it that you will feel happy if we start talking about physics first. It's okay for now.
Sounds good.
Okay. Then I understand the plan. Pressure, kinematics. Also there isn't there's no idea what will happen in term 3, right? For physics, no idea yet.
Term 3, yeah, no idea.
If you have information, tell me. We don't.
But I think
Mhm.
one of my friends whose physics teachers teach faster, they are currently teaching the energy.
Correct, which is the standard topic after the energy work power, right? Good news, it is not supposed to be that hard, all right? Okay, then the question is after that, what? Any idea or not?
No.
Okay, then let me take it this way. In term 3, there will be a term 3 exam, right? Must be lah, right?
Yes.
Then it will certainly include pressure and certainly the work energy power.
Okay.
So let's cover those two in this holiday. Then that is already somewhat stabilizing your term 3, already somewhat. Okay. As an additional thing, what we are aiming is actually a better SA2, right? Term 3 is smaller, SA2 is bigger, and pressure and work energy power will feature prominently anyway. Right? Anyway, lah. So that's the good thing. Lah. Anything else you want to tell me about physics?
No.
All right. Now you have your trip. I'm very happy, holiday and all the stuff. Simple question. Right now, do you feel tired because of the trip? Okay. Then if I say in the next week we should, do our catching up, will that be okay? The schedule, have you looked at the schedule? Are you okay with the schedule?
Yes, other than on Wednesday, but I think my mother told you already.
Correct. So Monday afternoon, Tuesday afternoon, Wednesday afternoon, the Wednesday night, right? There's an event. Then I just suggested to your mom, okay, let's reserve it to Thursday, and Thursday is a 5 to 6:30. Again, just want to confirm, is that okay?
5 to 1.
6:30. So it's not the Monday, Tuesday, Wednesday timing.
Okay.
Okay.
That's fine.
That seems to cover that chemistry and that physics. Hopefully that's enough. Yeah. Hopefully that's enough. What else to say? Sorry, one more thing. We're supposed to meet 2 times today, right? So it was now and night, and I may make a mistake. I forget that there's a birthday dinner for my father-in-law, right? I thought it was tomorrow. It turns out it's yesterday today. So is it possible if we switch the night one today into 5 p.m.?
5 p.m. to 6:30.
Yeah, is it possible? It's very sorry, this is very very late announcement.
Yeah, that's possible.
Okay, let's try, and hopefully you're not too tired.
Okay.
Now, lastly, I do notice that you came in at 2:30. Just want to confirm, is there a misunderstanding? Because supposed to be 2 to 3:30.
Oh,
that's why.
I thought 2:30 to 3:30. Sorry.
No, 2 to 3:30, right? Still, let's stop at 3:30 because you're starting at 5. That's quite close. Okay. So let's make the best of what we can do, right, for now. So let's go to Jamboard, right? And then so I want to have a feel about your pressure, right?
Okay.
You can use the paper to write things down, but now look at the Jamboard. Let me get this whole. Okay, I'm getting something and then I'm putting it in your Jamboard. Okay. The picture I'm showing you is not very clear because it is a screenshot. So now, do you see something in your page 2?
Yes, I can see it.
Now, let me make it clear, right? Clearer. So the mercury is there. The mercury is there. And then this one is the liquid wine. Now for this part of pressure, this is already, already not the most basic thing, right? So I'm choosing this to have a sense where you are. However, I would like to say first that this device is not what you will encounter in real life. This is a glass tube, simple stuff. They fill it with mercury and then liquid Y. For some reason, the liquid Y is higher than the mercury, even though the liquid Y is, shorter, so to speak, for some reason. Now, but this device you won't see in modern days because it is old technology. So back then, when they start to look at all this, this thing was very useful, right? Partly because mercury is liquid and mercury is super dense. You know how dense mercury is?
13 times of water around there, is it? No.
Yeah, you're correct. 13.6, but you're right. Around 13 times of water. So that means 1 liter of water. You can imagine 1 liter of water, lah. 1 liter of water is 1 kilogram, basically. Now, 1 liter of mercury, which is a lot, that weighs around 13.6 kg, something like that. All right. That is a lot because usually your school bag shouldn't be 13 kg lah. Usually our school bag is around 8 kg to 9 kg, maybe something like that. So 1.5 of our school bag and then make it into 1 liter. That's how dense mercury is. So happens it becomes useful. So happens the mercury is so happens liquid, so happens dense, and also chemically so happens is unreactive. It is even less reactive than copper. You have some idea about copper metal. Copper metal cannot react very easily and cannot react very fast. Mercury is even less reactive. In our case, that's a good thing. So happens mercury is what they use. We'll see why later very soon. There's one problem why you will never see this even in your physics lab. Never.
Mercury is poisonous.
Poisonous. The other thing is expensive lah. But if it is expensive, we will still buy. Mercury is also poisonous, right? So for all the usages of mercury back then, very, very useful. Now this is just something abstract on paper. I will have to apologize for that first, because we still keep using this as an example. Sometimes if I think of it, it is a little bit annoying. They will never show you in real life, even though it's very easy. And yet they ask you to think about all this. So sometimes I try to make it less abstract and more concrete. Okay, so that's what I'm trying to do here. Now, just to clarify one thing, if there is only mercury in the glass tube, is it possible for one leg to be higher than the other?
If it is only mercury.
Yes. Is it possible?
Yes, if the two openings are have different air pressure, not air pressure, just different pressure.
You're right. So you're introducing air pressure, and I totally agree with you, right? Let's say for now, just atmospheric for both legs.
Then it'll be the same.
All right. Now, in the risk of being obvious, if this is too high, then the left one, right? If the right is left, then higher than the left, then the right will push down more, right? Causing it to drop and causing the left to go up, right? If the left is higher than the right, the left will push down, going down, and the right will push up until until they are the same height.
Equilibrium.
Until equilibrium, correct. So again, it's so easy to see this in real life, but even I cannot handle mercury right now. Even I, if I want to have difficulty purchasing and handling it for you, right? But good that we can imagine that. Now, here is now 2 liquid. Here's now 2 liquid. Why is it possible that liquid Y is higher than mercury on the left?
Because it's less dense.
All right, you will be correct logically. I take this line. teacher like to, draw a line, and I also draw a line. I draw this line just below liquid Y, and I say, oh, mercury is pressing on this line, and liquid Y is pressing on, line of the same height. This force must be equal to this force. That means they are not moving, equilibrium. Does that make sense? So mercury needs less to press, so to speak. Liquid Y needs more to press. Therefore, liquid Y must be less dense than mercury. I agree with your logic. Okay, I agree with logic. Now, look at the answer. Look at the options. Immediately, one of them is ruled out. Which one?
The one that's lower. Wait, the A.
Why is A ruled out?
Because is it 6.9?
Yeah, they're a bit ugly. Yeah. So 6.9. This is 9.1. This is 12, and this is 20. Which one is ruled out?
Okay.
This is for liquid Y. Yeah? Density
liquid Y.
Wait. You say that liquid Y is less dense than mercury. And both of us think that makes sense, correct?
Yeah.
So one of the options are ruled out because, which one?
Less dense than mercury.
You
Just
think liquid Y is
more dense than mercury. So it's 20. It's D.
20 is gone. It cannot be 20, right? Because if liquid Y is 20, how can it be higher? It must be lower, then you push back the mercury, yada, yada, right? Making the mercury higher, same thing, right? So 20 is done. You're left with these three options. Now, I won't ask you to quote formula. Actually, I forbid you to use formula for a while. Just for a while. I know that you know some formulas, of course. Please don't use them. Please use your logic. Okay? Please use your logic to determine which answer you think might be correct. They give you the mercury density, they give you the height of the mercury, and they give you the height of liquid Y. That's it.
Okay.
Use your logic. You can write something on paper if you want. For your paper, I think you have the blur filter. In our case, once you start writing, please take off the blur filter. If not, I think I cannot see.
I think I accidentally turned it on.
So if you want to write something,
so I cannot use. So I don't use any formula.
Please don't. Just use your logic. Just you can calculate
logic,
but calculate your logic, not formula.
So can I calculate the volume?
If you want to, I don't think they give you enough, but you should try lah. You should try because I'm asking you. I just forbid you to use the formula. Use another way. Use another way.
Answer is B.
Sorry, which one? Sorry, B.
B. But I didn't do a bit of calculation. I just so basically the ratio. I did it by 8 cm and 12 cm. So the ratio is like 2 to 3.
Correct.
I get the ratio. Yeah. So it's 13.2 6 cm.
And then you just press calculator lah, or whatever lah, no problem, right? Okay. And if you press the calculator, actually, you'll find that the answer is very close to 9.1. Yeah. Using
9.15.
Yeah. So according to your logic, the answer should be B. Now, it doesn't mean that our logic is right or wrong, but at least our logic is saying that, first of all, it cannot be 20 lah, huh? Cannot be lah. Secondly, it will have some relationship to the 2/3 or 8 centimeter and 12 centimeter. So I think we should appreciate our logic for a while. Now I'm going to do it the formula way, and let's see what happens. Okay. Of course, you already know, then this should be easy for you. Okay. I will start with force. The force here will be the same as the force here. Let's call this point C, and let's call this point A, correct? If not, they won't be staying still. If not, they will be pushing it. So force A, force C. So I mean, it's weight, right? The force is because of weight. Now it will be causing a certain pressure lah. So A equals to pressure C, area of C. Will this be okay? Okay, the area of both is the same, right? So I can just cancel it. Can? Yes or no?
Yes.
So now I arrive at pressure at A equals to pressure at C. Your teacher will start here. I prefer to start at force. I think it's just easier to imagine the liquids pushing down instead of asking you to imagine the pressure caused by that. So I just feel more comfortable that there's nothing wrong with your teacher starting at pressure. There's nothing wrong with it. Okay. Now, this is from the pressure equals to force over area formula, correct?
Yeah.
This formula applies everywhere, including in liquid, including gas, not just solid. It applies anywhere and everywhere. Will this be okay?
Yeah.
The next formula does not apply everywhere and anywhere. Okay, it only applies for liquid. Rho A G HA equals to C G HC. The pressure of liquid will be rho GH only for liquid. This must be clear first. Only for liquid, not for gas, not for solid.
Okay.
Is it okay for that?
I'm a bit confused, but if you see the force over area formula can also be used for liquid, then why isn't it? Why for hydrostatic pressure is different?
Now, first of all, it's not different. I will show you later. I'll show you later. So what you're saying is, for hydrostatic pressure, which is what we're dealing with right now, I just use the formula. There you go, the rho GH formula, right? That must be that. Is that what you're referring to when you talk about hydrostatic pressure? Okay. Now I am using both. So I'm saying that in hydrostatic situation, meaning liquid, very simple. Hydrostatic means liquid, you know, just standing there lah, hydrostatic. Liquid can use both this and that, even though you don't have to. Let me show you why this is universal. This one is universal and this one is only liquid. Let me show you right now. Yeah. So I am going to do another thing. Now, you will agree with me first that the force is universal. Force can apply in liquid also, and no reason. There's no limitation there. Can yeah? Now I claim that no, I will not go through this. If I don't do, should I go? Let me think for. Okay, let me show it this way. Let me do this way. Let me do this way. So I will go through another route. Okay, I'll go through another route. The force is caused by the weight, the weight of liquid A and the weight of liquid at C, correct? Liquid X and liquid Y, basically. Okay. Am I correct? That's just the reason why you have pressure, you have force there. It's because of the weight of the liquid on top.
Yep.
Yeah. Then everybody knows that, you know, a weight is MAG and MCG, correct? Everyone understand? The G is the same, so I cancel that first. Okay, now mass of A. Mass is a liquid, right? Mass is liquid. So what do we get from the mass lah? The mass is,
the mass is,
in this case, I will split it to density and volume. Would that be okay?
okay.
Oh, wait. So that is nicer looking. I won't cancel the G. So that it's nicer looking. I won't cancel it. So I'll use rho of A, V of A, and G equals to rho of C, V of C, and then G lah. Would that be okay? Okay. Then and then I have to stop here. Now I now claim that using force over A is valid. Okay, let me show you what I mean. Now, okay, over area, I'm claiming that I can use this formula here. Remember, I'm claiming. So let's see what happens if I do that. Okay, over area, over area, over area, over area, over area, over area. I know that the area is the same. I'm just putting them in, right? Now let's see what happens if I do this. I am lacking in space. I have to move here. Because if I'm not supposed to do this, then something bad should happen, right? So rho A, the volume of A, please look at the volume of A for a while. Isn't that a cylinder in shape? You have not seen this thing before, but you know that this is a glass tube. And you can imagine that the glass tube is a hollow cylinder. If you have never been explained that, then this is the first time I explain to you. Do you want to see how it looks like in real life?
Okay.
Okay, so I'll share my screen first. So that let me get. In the end, it is much better to just see the real thing, right? The problem is everybody seems to be, well, not doing that. Everybody seems to be just drawing them right now because it is very difficult to buy one right now. At least buy one with mercury lah. Trying to find it for you, yeah, just a minute. Oh goodness me, it's so small, but this is the best I can show you right now. Right, so let me share my screen. You're looking at my screen, yes? Okay. This is a manometer, and manometer is what they call this thing, right? Let me show you in. There you go. Do you see that? That, although I cannot show you fully, but that looks like a tube, a cylinder tube, which is hollow because you're supposed to fill it. Below there is your U-shape. Look, there you go. That's your U-shape. The ruler in front is just for you to easily see the height. In the end, such a simple thing, right? You're supposed to have a tube and then you bend it. So simple, right? They make out of glass back then because glass doesn't react. Right now, this is plastic. Hopefully, they coat the plastic, right? So far, so good. All right, yeah. This is a tube. Now, why am I asking you to see this? Back to the Jamboard. In the Jamboard, I currently have volume. Volume is here. Currently, I have volume here. This volume, I'm supposed to look at the volume of the liquid here. Now, tell me what is the shape of the liquid here, therefore.
The shape of the liquid?
Yeah, the liquid is
cylinder.
Cylinder, simple, right? And what is the volume of a cylinder?
The volume is the circumference, sorry, area of the circle times height.
Correct. So we'll say, area of the cross-sectional, cross-sectional area times height. Okay, that's what I'm going to do. Okay, the area is a circle, I know. So I'm going to do this. V. Okay. So height A times surface area A. And this is your volume. And then G, and then over A. So C, H, C, area, G over A. Right? I just transform two volume into height times surface area. It's okay to do that. Can I? Is this okay? Okay. Now I cancel the area and the area, and now I present to you rho G H. What I'm trying to say to you is this: rho GH is there because I apply F over A.
Okay.
If this applies for liquid, certainly it means that this applies for liquid. It comes from that one. Something like that. Okay. So one more time, if this is good for liquid, the up here should apply for liquid. Now, in the end, this is much more suitable only for liquid, and this is suitable for everywhere else, so to speak, if you want. Can you? Yeah. So that is what I want to impress upon you. Useless only for liquid, and in fact, only liquid which is not moving. This one, please consider its application everywhere. You might need it. Yeah. Got it. Now, if I erase all that, you will now have rho GH because I can apply. And then I'm going to cancel the G. Would that be okay? The G stays the same. Okay. I want to find rho C. Am I correct? Yep. And then this is now HA over HC. Am I correct? This H will be your 8, and this C, HC will be your 12. And there you go. Just like your logic is 2 over 3 times 13.6. That will be the density of C.
Okay.
So far, so good?
Yep.
Now, obviously, your logic is currently faster than the formula method. Obviously, not by a lot, but at least it's faster. My point is not that your logic is smarter than the formula. The point is your logic and the formula are saying the same thing. It's very unlikely that they are both wrong. Okay. So your logic is correct because your formula is saying the same thing. Well, the formula is saying this. I think about it, and my logic also say the same thing. Hopefully, both of you are correct. No? The reason is because if you just apply the formula without thinking, you may actually apply it wrongly somehow or somewhere along the way. Use your logic and the formula together. You will be needing them a lot in the next question. Any questions so far?
No.
Now, this whole thing, you already understand or not? Am I saying something too easy here for you?
It's slightly new, I guess.
Slightly new. What do you mean by that?
I think we just went through the formulas and everything, but didn't really go through what's really behind it. I don't know. And especially for the hydrostatic pressure one.
I can tell you that this is not even exam. I mean, this is from no, this is this is an easy exam level question. Okay, I can tell you, right? And that's why you want tuition, right? So that we can discuss this kind of thing. Fair enough, right? Let me show you more then. Let me show you more. Okay, Andrew, in the next page, you will see another question, right? Please read them and tell me if you have any question to clarify first.
Okay, I get it.
All right, now let me ask you a question. Hey, how come P is higher than Q?
P is higher than Q.
Yes.
Q has N.
And P does not have. Okay, right. So how does having air make the Q lower? What's going on here?
Air has its own pressure.
And then the air do what with the pressure? According to you, I'm not asking you a fancy, and I'm asking what do you think?
The pressure, like how to say, acts on the water.
On the, in this case, mercury, and pushing it down.
Yeah. Yes.
Why isn't the P pushing back, so to speak?
It's a vacuum, I guess.
Oh no, yes. So when I say P, I mean the liquid P lah. I mean the liquid P, right? I know there's no pressure here, but I mean the liquid P. Why isn't this P liquid pushing back so that this goes up?
Because the atmospheric pressure is pushing the liquid up P, like from outside, I guess.
Which is not wrong. The way you say that is not wrong. Really, the way you say that's not wrong. Right. Okay, never mind. Okay, but I think I understand what you're saying, right? Okay, it's really not bad at all. Now, there is no question here. I didn't copy the question. I'm just gonna guess what the question will ask you. The question will ask you, what is the pressure of the air inside tube Q? Can you find that?
Oh, okay. Pressure of the air.
Inside the Q.
Okay.
At this point, I'm still feeling where you are. So if you feel that you're not sure what to do, don't wait too long. But if you feel that you can try something, also try. Remember, this is not exam. I'm not I'm not gonna scold you for not knowing things. I really have to know where you are.
I think something to do with the difference in height then.
Right. Which is what teacher will do, right? Which is what teacher will do. So I'm gonna make it clearly why that is true, so that is your logic working. You understand it lah. It's not just about formula, okay? Oh, right. In fact, we shouldn't jump into formula every time you see a question. That, unless you're very good, that will be wrong lah, especially in a topic. So I have two options. I have two options for line. Okay, I have this bottom line, and later on I'll try this green line. Okay, I won't be trying anything else. For the red line, I propose it is just much easier if you think about this as, hey, the liquid is pressing down, and hey, this also pressing down. Just think of it that way, okay? So your logic, which one is comfortable for you? You want to start from this force here will be the same as this force here. Why? Because if one is greater, this is going to go up. If this is greater, this is going to go down. The fact that this stays the same means he is pressing in the same way as this is pressing. Okay? Your logic will call that force or pressure. Let me just confirm that. Force or pressure. Force at P equals to force at Q, or pressure at P equals to pressure at Q. Your logic say what?
Yeah. No, sorry. Force at Q and A or P and Q.
Right, so one more time. Your logic, when I say this thing is pressing down in the same way that this thing is pressing down, okay? Which one do you want to think about? Do you want to think about it as force at P equals to force at Q? Or do you want to think about it as pressure at P equals to pressure at Q? Which one do you want to?
Pressure.
Okay, then let's start from pressure, because you don't mind thinking about it that way. Now, tell me, what is the pressure at P again?
At P, the pressure.
Oh, yeah, it's because of the guy on top, right?
Yeah.
The guy on top. The guy on top is a liquid mercury, correct or not?
Oh yeah, the mercury, yes.
There is some guy on top of A. Sorry, I better put this at A. Why do I have to say it's P? Sorry, A better. Right. So
okay.
It's the what is
column of mercury
due to that liquid? That would be what?
0.75.
No. Rho GH lah.
Rho GH.
And the 0.75 is useful. There you go. That's the 0.75 lah, correct? Okay, and then times A, and then I know the rho of mercury. What is it?
13 points. Sorry.
Yeah, that's 13,600.
13,600.
And that's the pressure at A due to the liquid above him. Okay. Let's talk about the pressure on top of Q. So what is it caused by?
Both the oxygen and the column of mercury.
Okay. So what can we write about that?
Rho GH of the mercury plus the density of oxygen.
Yeah. Okay. First, I'll write down 13,600 times 10, times 0.6. Okay. Very happy with that. Right. And then you will, I understand that you're using the word density for gas. I understand. Can I, from now on, use the word pressure? Dense means it press more, lah, if that makes sense. Would that be okay?
Yes.
Okay, so pressure of the gas at Q, right? So pressure of gas, okay, at Q lah, right? That's it, look. And then this is plus the pressure of gas, right? So if he asks you, what is the pressure of that gas, right? If let's say he asks you, can you do it?
What's the pressure of the gas?
Correct. That's the question now. What's the pressure of gas at QQ?
I just use the calculator, I guess.
Okay, let's stop there. It's okay. So at this point, that's math already. Simple math. Your physics is done. And yeah. Okay. Now, my question is, can I use green line instead? Can or not?
Green line.
Yeah. Can I use green line instead of red line? Just now I use red line.
Okay, I'm not sure.
Okay, I'm going to challenge you. I just name this B and C first, okay? Easy. B and C. I'm going to challenge you to try to use line B and C. Go ahead, please. Give it a try.
Okay. So basically, the answer gives me 13640. 20,400.
Okay, that would be a Pascal, right? So
Pascals for the pressure of
20,400 Pascal. Now, my question is it the same or different with the red one? You can find out lah. Please give it a try.
Pascal, do I write the P as a big P or a
Yes,
small P?
it must be a big P. Yes.
Okay. The A is small.
Yes, it must.
Okay.
Is it the same with the red line?
It's the same.
The same. No? My question is this good or bad for understanding? I can use red line. I can use green line. Good or bad?
Yeah, let's go for understanding, I guess.
Okay, you understand something out of all this. Okay, then just for curiosity, let me ask you, can we do green line? Cannot.
Blue line?
Yeah, blue line. Sorry, blue line on top. Can we do blue line?
Yes, but it's harder to find the height in this case.
Because it's random.
Yep.
Very surprisingly, this height we don't know, but this height will be the same as this height, right?
Yeah.
Surprisingly, when we put it in the equation, acknowledging that is the same height that we don't know, they will also just cancel each other.
Oh yeah.
Surprisingly. So not knowing the height doesn't matter. A random line here doesn't matter because these two heights will be the same. Okay, let me test you again. Is it possible to take a yellow line?
Yellow line. No.
Oh, possible. Same thing.
Really?
I have an extra height here, which obviously we don't know because it's random, right? But same thing, it will be 0.75 plus a random height. This will be 0.6 plus a random height, and they will end up simply canceling each other.
Okay.
Green, blue, red, yellow. I'm not saying that their pressure is all the same. That's not what I'm saying. But I'm saying that all of them can give you that.
Got it.
Okay. So far, so good?
Yeah.
You're sure this is not confusing?
No.
Right. You are about the level of Aiden. Do you mind if we just wait for Aiden on Monday? Then, you guys can go on the same speed.
They will just do chem first. Sure.
Right. Just do chem first. Right. So correct. Yeah. You feel that this is the pressure discussion that you need. Correct. Yeah.
Yep.
And if I go even harder, that will be good. Correct?
Yeah. Yes.
Okay, good, very good. All right. So a bit of chem. Oh, except for the fact that now is 3:30. Correct? I'll see you at 5, and we'll immediately do chem.
Okay.
Is there a homework for chem? Let me ask again. If there is, can we see them later? That might be helpful.
I don't think there is homework for chem.
There is, then that's good. That's good. Then we'll just whack everything else. Okay.
I don't think there is.
Correct. Again, in case there is a physics homework, bring them out next week, something like that. Okay. I'll see you in 1.5 hours. We'll talk about chem. All right.